you guys already go through the lectures, right? So for the chapter 8, okay, for my part, uh, okay, I'll tell the format of the question now. Okay, the format of question, you have 5 questions. You have to answer 5 questions, right? So there'll be 3 compulsory questions and 2 optional. So for optional, you have to choose one. Okay, 4 and 5 will be the optional question. 1, 2, 3 will be the compulsory question. All right. So that's for the format. And for question 1 will be the part from Dr. Marni. Question 2 will be the questions part from Dr. Fadila. And question 3 will be from my part lah. Okay, then 4 and 5. For 4 and 5, there'll be 3 sub questions. So for question 4, there'll be ABC, and question 5 has ABC. So part A will be from Dr. Mani, part B will be Dr. Fadila, part C will be from my part. So that's the format of the question, right? So for question 3, there'll be 4 sub questions. Okay, so all the 4 sub questions will be covering my part. Okay, so you have to go through the internal memory. Okay, so you know about the internal memory, right? Okay, RAM. So you have already done the assignment. Okay, so assignment, I hope you guys already understand, okay, about the RAM part. So DRAM, SRAM, okay. So how it's actually the mechanism of the principal working mechanism of the RAM. Okay, SRAM is DRAM. So we also have read-only memory, okay, PROM, and also read-mostly memory, which is EPROM, EPROM, and also flash memory. Okay, then after that will be we have the chip logic. Okay, in the chip logic we have covered all the how the chip is organized. Okay, inside that. If you went through the lecture that I uploaded, so you would understand this, right? Then after that, we have this is the how these chip pins are organized. Okay, so we are using the multiplexer here. Okay, and also the buffer. So we only need a minimal pins. Okay, instead of having this much of pins. Right, so we use the buffer and also multiplexer to reduce the number of pins, and also to, I mean, like with the minimum number of pins, we can expand the selection of the chips, the cells. Okay, so this is the cell. So inside the memory we have cells, right? So we have control, select, and also sense, read and write. So if you want the control pin actually selects, okay, the control pin actually controls the cell. So this is the selection pin. Okay, it selects the which cell we want to read or write. Okay, so this is how the cells are organized. And this is the chip, and we have error correction, okay, code function here. Okay, so this is the Hamming error, and if you guys note, this is how the error is corrected here. Okay, so when data in goes, so it will create another copy Okay, so using the function of f, okay, so it will create the copy. Then once it store inside the memory, after that, if you want to read back the same data, okay, so it will output the copy of it and it will compare, okay, using the XOR, right? So it will go through the function here. So it will compare whether this and this is the copy and the original, okay, it is same or not. All right, if there is any error, there will be the correction, there'll be correction done, okay, and then only we will read the data. If not, we'll be reading the wrong data, right? So this is why we're having this error correction code function here. Okay, so we have aiming code. Okay, and this is the method. Okay, to calculate. I hope you guys already went through this. Okay. Okay, so advanced DRAM organization, SDRAM. So we have another different types of RAMs here. Okay, double data rate, DDR, SDRAM. So currently we are using the DDR RAM. Okay, in the market, the most commonly used RAM is the DDR type. Okay, in the PC and also laptops. So we have flash memory here. Okay, so we have NAND or okay, NAND cells and also all NOR flash, right? So we have different two types of flash memory here. Okay, so okay, do you guys have any questions from this part? Internal memory. Guys, do you guys have any question? So you guys can go through, right? Go through the chapter internal memory, right?
Cannot.
Huh?
Boleh.
If you don't have any question, then I can't give. Are you guys okay for this chapter? Guys.
Doctor?
Yeah.
For the error correction, should we like make this correction by the diagrams, or how is gonna be like to do this error correction, or we should to understand the concept?
Yeah. So you guys have to understand the concept here. Okay. How the single error correction and double error correction is done, right? So if you guys see, so we use this NOR, okay, NOR method. Sorry, XOR method here. So we use the XOR method here, then to identify the chip, the bit changes in the bit. Okay, so if you go through, you will understand how the error is identified. Okay.
Okay.
So any questions from here?
Doctor,
Yeah.
in this chapter, do we need to know the more details about the internal memory, or just to know the concept and like the upper things?
Okay. Okay. So for this chapter, you guys try to focus on the error correction part. Okay. So the error correction part, try to focus on that. Maybe from slide 24 up to 37. Okay.
Okay, Doctor. Thank you so much.
Okay. Try to focus on the error correction part lah. Okay. Any questions from this part, chapter, internal memory? Nothing? Then I will proceed to next chapter. Okay. So next chapter will be the chapter external memory. Okay. We have internal memory just now, RAM. This one is the external memory. Your hard disk. Okay. So you're saving all the data, all your files in external memory, right? Hard disk. So for this, we have a few types of disk and memory types. Okay. So first is the magnetic disk, right? So you can read how the disk actually, how it's actually the data is stored inside the disk. Okay. So you can use the disk classification here. You can read it out here, right? Then after that, this is the hard disk that we have, right? So now we already have SSD. Okay. So we have HDD, hard disk drive, right? So commonly we are using HDD, hard disk drive. And now most of the laptops already have the SSD. Okay. So SSD concept is more like RAM. Okay, it uses chips and cells. Okay, so while the HDD it uses the hard disk type. Okay, so sometimes we can hear the noise, right? The disk noise. Okay, so that uses the disk type. Okay, and mostly they're having both. Okay, SSD and also HDD. Okay, another one is the RAID. Okay, redundant array independent disks. Okay, this one they actually used to do the cloning lah. Okay, if you want to clone your data, okay, mostly they use for the servers. Okay, so they want to back up the data. So and we have few levels of RAID. Okay, so you can read it out. So SSD, solid state drive. So we have SSD and HDD here. So SSD is they use the concept of NAND flash drive, and also we have NOR flash drive. So there's now we studied on the internal memory, right? Okay. So it's like more like internal memory type. Okay, SSD. Okay. So then after that we have CD-ROM. Okay, we have CD-ROM. So these are you can read by yourself. Okay, how we read and write. Okay, there are CD recordable. Okay, write once and read many. Okay, and this one CDRW. So nowadays it's very seldom we are seeing the CD. Okay, but last time, a few years back, like 10 years ago, 15 years ago, we used CD. Okay, so there are two types, CDR and also CD-RW. So we can repeatedly write and read. Right. So we can delete the data, and also we can copy again on the CD. Same like the flash memories that we are using just now. So we have thumb drive, right? Okay, so we have flash drives. So now we can delete the data. We can write a new data, right? So same concept. We have two types. This one CDR, we only can write once. Then we can read many times. But this one, it's like same like the flash drive. We can read and write many times. Okay, so we have to understand how the writing mechanism is done, right? On the CD. Okay, then after that, this is the magnetic tape. So nowadays we don't use this magnetic tape. Those time we use the magnetic tape. Okay, so you can read out this one as well. So this technology is not used in current days. Okay, but we have to know about this magnetic tape. Okay, what is magnetic tape? How the reading and writing process is done on the tape drives. Okay, so for the external drive, we have magnetic disk, which is HDD. Then after that, we have RAID. Okay, redundant array independent risks. Okay, this is used for the cloning process. Then after that, we have SSD. Okay, so you guys have to know how the SSD works actually. Okay, so we have to know the practical issues. What are the SSDs and HDD? Okay, then after that, we have CD-ROM, right? And we have magnetic tape. So from this chapter, do you guys have any questions?
Sorry, Doctor, I have a question.
Yeah.
For the external memory, do we need like to focus on a specific type of memory, or just we need to focus on all the types that we have in our chapter?
Good question. So indirectly you're asking for tips, is it?
Not 100%, Doctor.
Okay, so it's okay. We call it this as a revision class, but can be a tips class also lah, right? Okay, so I want you guys to pay attention on the CD-ROM. Okay.
Okay, Doctor. Okay.
All right. So try to understand how the CD-ROM actually works. Okay. So you guys have to understand all the external disk, external memory. So since all these are we are using in daily life. Okay, in our laptop, you have all the external memory, but nowadays it's very seldom to use CD-ROM lah. Okay, but we have HDD, SSD. Okay, so mostly commonly we are using magnetic disk and also SSD. Okay, for these servers, there we are using the RAID system, RAID concept. Okay, for servers we use RAID. So mostly commonly we have HDD and also SSD, but nowadays we don't have not much using the CD-ROM. Okay, so try to read about the CD-ROM. Okay, but you guys have to understand other external memories as well. Okay, so right. So any other questions for this chapter? All good? Okay, so I don't want, because I don't want you guys to stress yourself lah. Okay, so that's why I just want to reduce the scope. It's the scope lah for you guys. Okay, so for chapter 8, as long as I told you, try to understand the error correction. Okay, try to focus on the error correction part, right? From slide 24 until 37. Okay. Then after that, for chapter external memory, you guys focus on the CD-ROM part, right? CD-ROM from 42 until 54. Okay. until 54. Okay, try to understand how actually the CD works lah. Okay. All right, any questions so far?
Doctor, last question. For
Yeah.
the cache memory, it will be the question 3, right?
Cache memory. Cache memory, I don't think so. Got question from the cache memory.
Okay. Can we know, Doctor, the specification of the questions? Like for question 3, what chapter will be covered, and 4 or 5?
Yeah, all the chapters. For question 3 is from my part. So from my part, I cover external memory, internal memory, external memory, input output, parallel processing, and also performance issues. Okay. So question 3 will be have 4 sub questions. Okay. For question 3, we have 4 sub questions. So you have to answer all so each sub questions from one chapter lah. So one question from say 3A from internal memory, 3B from external memory, 3C from input output memory, input of chapter, 3D from performance issue, something like that. Okay. So I already reduced the scope for you guys. Okay. Reduce the scope for you guys. Try to focus on the chapter 8 internal memory. Try to focus on the error correction part. Okay. And for error correction, try to focus more on the theory part rather than the calculation part. Okay. So then after that, for the chapter, the next chapter, external memory, try to focus on the CD-ROM. Okay. Okay, all good so far. So I think, so I didn't have the opportunity to do a face-to-face class. Okay. So and I planned for the face-to-face revision class, but I couldn't make it. So that's why I'm doing it online. At least I can interact lah, because I didn't have opportunity to interact with you guys in the lecture. In the lab, yes. In the lab, maybe just my group mates. Okay, my group students. So other group students, I didn't have opportunity to interact. Maybe during the lab test or the Viva. Okay. So other than that, I didn't have opportunity. So this is the time lah. This is where I'm doing the revision class. So I'm trying to reduce the scope, so make it simpler for you guys, right? So chapter 1, internal memory, external memory done. So next we'll go to any questions so far? All good? Okay, all right. If all good means, then we'll go to chapter input output, right? Okay, so for this chapter, this is the I/O module here. Okay, so we have why we are having I/O module, because we want to connect the external devices. Okay, such as like keyboards. Okay, we have printers, right? So whatever I/O external devices that you want to attach or communicate with the PC, so you have to have a I/O module. Okay, if not, there'll be difficult. It's difficult to communicate with these devices, right? Sometimes you have Bluetooth, okay, wireless mouse, right? We have wireless mouse, wireless keyboard, so you have to have a Bluetooth there. So all this I/O module is the one. It's actually in charge. Okay, in charge for the communication between external devices and also laptop or PC. Okay, so you guys can go through here. I don't think I haven't uploaded this module, right?
Yes, doctor. It didn't have an e-learning.
Okay, I'll upload it. Okay. So you can read it. Okay, you can go through on this part. Okay, let me wait. Give me 5 minutes. I'll upload first. Input module. We have this is the module here, right? So this is how this links to the peripheral devices, right? So this is connected to the control line, data line, and also address line here. So we have external devices. There's a human readable. Okay. So we have monitors. Okay. Monitors. Mission readable. Magnetic step system sensors, actuators. Right. Then after that, we have communication suitable for communicating remote devices such as terminal, mission readable devices, and another computer. Okay, if you want to connect computer to computer, right? So we need the communication networking, right? So it's all we need the I/O module for that, right? Okay, so you guys can read on this keyboard monitors, right? Then after that, the major function of input output module, So this is the block diagram of the IO module. Okay, so inside the IO module, this is the interface to the external device, right? So external device interface logic, external device, you can have data status control here, right? And this is the interface to the system bus, okay? Data line, address line, and control line. Okay, inside here we have IO logic. This is data registers. Okay, so this is how the IO module looks like. We have 3 types of IO module, right? We have program IO, interrupt driven IO, and direct memory access, right? So you guys have to know what is program IO, right? Program IO is the data exchange between the processor and IO module. Processor executes a program that gives it direct control of the IO operation. So when the processor issues a command, it must wait until the IO operation is complete. If the processor is faster than IO module, this is a wasteful process time. So this is for program IO. Another one is interrupt driven IO. So processor issues an IO command, continues to execute other instructions, and is interrupted. Okay, this is interrupted by the IO module when the latter has completed its work. So this is for interrupt driven IO. And another one, we have direct memory access, DMA. So the IO module and the main memory exchange the data directly without the processor involvement. Okay, so the communication is between IO module and also the main memory here. Okay, so this is the direct memory access method. So you guys can see here. Okay, so IO to memory transfer to processor. So this is we call it as through. If we use the processor, involvement processor, we have 2 types: program IO and interrupt driven IO. Okay, so direct input output to memory transfer. So we call it as direct memory access, DMA, use of interrupts. Okay, so this is the technique, IO technique. So you guys can read it on the instructions. Okay, mapping summary, and so you guys have try to understand interrupt driven IO here, right? And after that, drawbacks of the program and interrupt driven. Okay, then after that, what is DMA? Okay, direct memory access. Okay, so and we have DCA as well. Okay, we have DMA and also DCA, right? So try to understand what is DCA here. Okay, and this is the evolution of IO function, and we have USB and Firewire serial bus, SCSI, okay, small computer system interface. This is the SCSI, okay, and we have this Thunderbolt here. Okay, this one usually we have for the most recent and fastest peripheral communication technology to become available for general purpose. We have Thunderbolt here. Okay, so this is, and we have here, this is with we call it as PCI Express and SATA. Okay, serial advanced technology attachment. So we have Ethernet cable. So we connect the Ethernet cable to your laptop and PCs. Okay, so it's all connected through the communicated through the input output module. So without input output module, you can't communicate the external devices. Before that, all is happening inside. Okay, in the internal memory, external memory, all inside the PC. This one, if you want to communicate from another PC or another external devices, you need the input-output module. Okay, so for Wi-Fi here, okay, then after that, okay, so this is how the frames lah. Okay, how it looks. We have a PCI, okay, PCI driver here, input-output carriage, okay, and internal battery is optional. So this is like we have the PCIe lah. Normally we use the PCIe here, and we have the Ethernet cable, plug-in cable module. Okay, so sometimes we use the Wi-Fi module, right? Wi-Fi module as well. Okay, so it also need the input-output module. Okay, all right. So far, any questions from this chapter? Okay, so since I didn't cover this chapter yet, okay, so for this chapter, you guys try to understand on the what is program IO and also interrupt driven IO here. Okay, so we have three techniques, right? We have program IO and also interrupt driven IO. So try to understand what is program IO, interrupt driven IO, and direct memory access. Then after that, you guys have to know what's the differences between this interrupt program IO, interrupt driven IO, and DMA, and also DCA, and what's the advantage of DMA and DCA. Okay, so try to read on the okay, so drawbacks. What are the drawbacks of the IO input, program IO, and also interrupt IO. Muhammad Tafis. Mute. Okay, so try to focus on this and what is the advantage. Okay, what's the advantage of the DMA and also DCA. Okay, any questions? You try to read from page 25 to 37. Okay, try to focus on from 25 to 37. Okay, so far good. Any questions from input output module?
Doctor,
Yeah.
this chapter 10 is for which question?
Yeah, question 3.
Okay, Doctor, thank you.
There'll be one sub question for this chapter. Question 3. Okay. So question 3 have sub questions. Question 3 is not from one chapter. Question 3 is from multiple chapters. We have sub questions A, B, C, D. Okay, so each sub question from one chapter. Okay. So external memory, we have external memory for one question, sub question. Internal memory, one sub question. Input output, one sub question. Okay. So we have all the sub question from each chapter. Right. So trying to focus on from 25 to 37. Okay. Yeah.
Sorry, Doctor. How about question number 4 and 5? It will be from specific chapters or like multi chapters as well?
4 and 5. 4 and 5 from multiple chapters. Because 4 and 5 we have 3 sub questions. 3 sub questions. So each sub question will be covering all parts from all the lectures lah. I mean, like, okay, let's say for example 4A from Dr. Mani part, 4B will be from Dr. Fadila, 4C will be from myself lah. Okay.
Yes, okay, Doctor. Thank you.
All right. Okay. So, all right. So that's for the chapter input output. Then after that, we'll go into the performance issues chapter here. Okay. Okay. For the performance issues, we have what are the issues arises in designing a computer here, right? So that's the performance issues now. So the cost of computer system continues to drop dramatically while the performance and capacity of those systems continue to rise equally. So today laptops have computing power of an IBM mainframe from the 10 or 15 years ago. So processors are so expensive. Okay, nowadays processors are so expensive. So we have image processing. We have a lot of processors based on the image processing. Okay, 3D rendering, speech recognition, video conferencing, and a lot of things. Right. So techniques built into the contemporary processes include pipelining, branch prediction, superscalar execution, data flow analysis, and so speculative execution. Right. Okay. So performance balance here. Okay. This is the performance balance. So if we see here, we have adjust organization and architecture to compensate for the mismatch among the capabilities of the various components. So we have different, this is how the performance balance is done. So you guys can go through this, right? So we have problems with the clock speed and logic density here, and we have multi-core processors. So we have multi-core processors as well. Okay, so many integrated core MIC graphic processing unit. We have GPU. Okay. Okay, so this is more on the performance issues here. Okay, for this chapter, you guys can focus on the guys can focus on the Amdahl laws law. Okay, Amdahl's law, latest law, right? You guys can focus on that. Okay, this is mainly on the, actually this chapter 2, sorry, this chapter 2, previously the performance issues was chapter 2 actually. Then I changed this semester, I changed to chapter 11. Okay, so I didn't update this. But you guys can focus on the laws now. Okay, you guys have to know what is Amdahl's law. Actually deals with the potential speed up of the program using multiple processors. Okay, so if we increase the processors, number of processors, so the processing speed will increase as well. So illustrates the problems facing industry in the development of multi-core machines. Okay, so software must be adapted to highly parallel execution and environment to exploit the power of parallel processing. So can be generalized to evaluate and design technical improvement computer system. Okay, so try to understand this and try to understand the Little's law as well. So fundamental and simple relation with the broad applications, so can be applied to almost any system that is statistically in steady state and in which there is no leakage. Okay, so queuing system, if server is idle, an item served immediately, otherwise arriving item joins a queue. So you have to know the queuing system as well. There can be single queue for a single server or for multiple servers. So what is system clock here? Okay, how the clocking system actually works to transfer the data. So you guys have to understand that. Okay. Try to read this one as well, multi-core, okay, and GPU, okay, and how the laws actually works, okay, how the law is related to this multi-core processing, okay. All right, so that's for this chapter. Any questions so far? Any questions, guys? Right. So I dah reduce scope, banyak scope lah for you guys. I already reduced all the scopes for you guys. I tried to help you guys lah. Okay. So no worries. Don't worry. I hope you guys can do well. Okay, give me 3 minutes. Okay, give me 3 minutes. Yeah. So, question 3 already covered. Okay, already covered from chapter internal memory, external memory, parallel, performance and also input output module. Okay, for this chapter, parallel processing. Okay, parallel processing will be on the question 4 and 5 lah. So you have to choose either 1 or 4 and 5. So there'll be question for parallel processing. Okay. So what is parallel processing access? So we have multiple processors. So multiple processors, right? So you guys have to understand. So nowadays technology, we have 64 core, okay, 32 cores, okay, processors. So parallel processing, how the parallel processing is done, okay. So for you guys, for the mini project that you guys did, actually is a single cycle processor, 16-bit, okay. But nowadays we have 64-bit already. Okay, current technology, now we are using 64-bit processor. So in the mini project, I asked you guys to design 16-bit processors, right? So that is single cycle. So we have multi-processor as well. Okay, multiple processor. So how the multiple processor is organized? So this will cover on that part lah. Okay. So this is like single instruction, single data. Okay, SISD stream, single processor execute a single instruction stream to operate on the on data stored in a single memory. Okay, in a single memory, uniprocessors fall into this category. So this is single instruction, single data here. Okay, we have single instruction, multiple data stream. Okay, a single machine instruction controls the simultaneous execution of a number of processing elements on a lockstep basis. So we have vector and array processors fall into this category, and we have multiple instruction and single data stream. This is a sequence of data is transmitted to a set of processor. Okay, we have multiple processors here, each of which execute a different instruction sequences. Okay, so it will execute. So now, we have multiple instructions, right? So each instruction will be transferred to the each processor. Okay, so each processor will execute a single instruction lah. So multiple instruction, multiple data. So as a set of processors simultaneously execute different instruction sequences on the different data sets. Okay, so SMP cluster NUMA system fall fit into this category lah. Right. So this is how this multiple processor organization is categorized. Okay, so we have single instruction, single data stream. Okay, as I told you just now, we have SISD, SIMD, MISD, and MIMD. Then we have multiple classifications. Okay, for MIMD, we have shared memory and distributed memory. So inside that, we have SMP, symmetric multiprocessor, and also non-uniform memory access, NUMA, right? So we have alternative computer organizations here. This is how the SSI, all the categories. Okay, so you can use, you can see this with the distributed memory. All right. So how it is communicated, the instruction is transferred actually. Okay. So if SISD means just a single stream. Okay. Single data, single processor. So as you guys did the mini project, is fall into this category. Okay, single clock, single processor. All right, so it's all in a single line. So we have single processor and also multiple instructions. So let's say, for example, we have it can be transferred into multiple lines here, and this is MIMD. All right. So MIMD means we have multiple instruction. So multiple instruction is transferred to the multiple processors. Okay. So shared memory here. Okay. This is interconnection network. So this is how it's working, actually working principle of that. Okay. So you guys have to understand, okay, the categories of the multiple process organization. Okay. So then after that, you guys have to know symmetric multiprocessor. Okay. So what is symmetric multiprocessor? SMP. So a standalone computer with the following characteristics. Okay. So two or more similar processors of comparable capacity. So processors share same memory and I/O facilities. So all the processors share access to I/O devices either through same channel or different channels giving paths to the same devices. So all processors can perform the same function and symmetric. So this is the symmetric multiprocessor here. So all the processor can perform the same functions. Okay, so it is called as symmetric. So and all the processors share the access to the I/O devices. So this is the characteristic. Okay, characteristic of the symmetric multiprocessor. You guys have to understand that. Okay. Okay. All right. So this is the block diagram. Okay. How the generic block diagram of the tightly coupled multiprocessor. Okay. We have multiple input-output modules, and we have multiple processors. So this is the interconnection network, and this is the connection to the main memory here, right? So it depicts general terms of the organization of the multiprocessor system. So there are two or more processors. So each processor is self-contained. So including a control unit, so ALU registers typically on or more levels of cache. So each processor has access to a shared main memory. Okay, this is the shared main memory here, and input-output devices through some form of the interconnection mechanism. So the processors can communicate with each other through memory. Okay, the processor can communicate. So you guys have to understand here, the processors can communicate with each other through memory, messages and status information left in common data areas. So it may also be possible for the processor to exchange signal directly. So the memory is often organized so that multiple simultaneous access to separate blocks of memory are possible. So in some configuration, each processor may also have its own private main memory. Okay, so each processor might have its private main memory and input-output channels. Okay, this is a shared main memory here. So all the processors will be sharing the main memory here, right? So for the mini project that you guys did, okay, so we have a single ROM, right? Single ROM is communicated with the single processor. So all the instruction is sent to the processor. So CPU will be executing the instructions one by one. Okay, but this one, multiple processor, it can execute instructions in parallelly. Okay, this is what we call as parallel processing. Okay, instead of doing instruction just in the mini project, since you guys already done the mini project, so I hope you guys can understand. So in the mini project, the instruction is executed for each clock cycle, right? Okay, one by one. So we use the program counter. We use the program counter to increase the sequence, right? So when the sequence is increased one by one, so all the instructions is executed one by one, right? That's for single cycle CPU, right? But this one is for multiple processes. We can do the instruction, we can execute the instruction parallelly. This is what we call as parallel processing. So don't have to, we can save the time. Okay, instead of doing one by one, so we can execute all the instruction parallelly to save the time. Okay. So far, any questions? Do you guys understand so far? So now you can understand, right, about the mini project. Okay. So why we need a parallel processor, multi-processors. Okay. So why we need multi-processor? To save the time. Okay. Save the time. So instead of processing the instructions one by one, you guys can process the instruction parallelly. All right. Okay. So this one, the most common organization. Okay, for this chapter, I won't give any tips. Okay. Wait, oh, there are some questions here. What slides we need to focus in chapter? Walid, directly asking question. Which slides already get bored, is it? Okay, doctor may ask for both internal and external chapters are for. Okay. No, for 4 and 5 will be from the parallel processing. We need tips, please. We don't have the IO memory selection in. Okay, 4C, what chapter? Yeah, 4C will be the chapter parallel processing. 4C and 5C. Yeah. 4C and 5C will be parallel processing. What slides we need to focus on this chapter? Okay, for this chapter, I won't give any tips. Okay, because this is your effort. Okay, this is effort. I already give tips for other chapters. It's a very focused tips. You just guys focus on the slides that I told you guys to focus, right? For this one, I won't give any tips, but I'll try to reduce your scope. Okay. Because I want to see your effort. Okay. If you really put effort and you understand and you did your mini project. Okay, and you did your mini project by yourself. If you understand the mini project, okay, you can understand this chapter. If you didn't do the mini project, you just tumpang with your friends. Okay, so it will be difficult for you guys to understand this chapter. Okay, so it will determine your grade. Okay, so those who have more understanding, better understanding, they will get A. So then after that, the others, they will get other grades. Okay. But I try to explain to you guys. Okay, listen carefully. Don't just wait for the tips. Okay, try to understand. This chapter, multiple process organization, is more on parallel processing part. If you guys understand, if you guys did the mini project, okay, at least you guys understand the mini project, you will understand much better this chapter. Okay. So this is the symmetric multiprocessor organization here. Okay. So we have inside the processor, we have cache memory, right? Okay. So we have cache memory, and also we have the main memory system here. So we have the IO subsystems, and we have IO adapter. This is the buses, okay, shared buses, control bus, signal bus, and all these things. Okay, we have this. So all the processors are connected to the shared bus, and this is the shared main memory here. So, but sometimes each processor might have its own private memory lah. Okay. Okay. So the most common organization for computers, workstations, and servers is the time shared bus, right? Okay. So the time shared bus is the simplest mechanism for constructing a multiprocessor system. Okay. So you guys use the wire. Okay, wire, right? Wire is actually bus. Okay. In a mini project, you guys use the wire system, right? Okay. Transferring the data from ROM to RAM, ROM to processor, okay, ROM to ALU module. So you all have buses, right? Data bus, okay, control bus, and all these things. That's why I'm telling you, if you guys understand the mini project, it will be easy for you guys to understand. Okay, so the structure and interfaces are basically the same as for single processor system. Okay, and that uses the bus interconnection. The bus consists of control, address, and data lines. Okay, so we have control bus, address bus, and also data bus to facilitate DMA transfers from direct memory access. Okay, to facilitate DMA transfer from IO subsystem to processor, the following features is provided. Okay, so it must be a possible distinguished module. So on the bus determine source and destination data. So any IO module can temporarily function as master. So a mechanism is provided, arbitrate competing requests for the bus control using some sort of priority scheme. So time sharing, when one module is controlling the bus, other modules are locked. Okay, so when one module is controlling the bus, other modules, IO modules, are locked out and must, if necessary, suspend operation until bus access is achieved. The uniprocessor feature is directly usable, is an SMP organization. In this latter case, there are now multiple processors as well as multiple input-output processors, all attempting to gain access to one or more memory modules in the bus. So the bus organization has several attractive features. So guys can read by yourself what are the advantage, disadvantage of the bus organizations here. Okay, and multiprocessor operating system. Okay, so what is the design consideration? Okay, you guys have to understand for designing the multiprocessor operating system, what is the consideration that you guys have to take into account. So simultaneous concurrent process here, right? And scheduling, synchronization, memory management, and reliability, and fault tolerance. So this is one routines need to be rewritten to allow several processes to execute the same IS code simultaneously. Okay. Let's make it bigger. So scheduling. So any processes may perform scheduling. So conflicts must be avoided. Synchronization. Okay, with multiple active processors having potential access to shared address spaces or I/O resources. So synchronization is a facility that enforces mutual exclusion and even ordering. So memory management. Next is memory management. So this is the design consideration you guys have to know, right? So memory management, in addition to dealing with all of the issues found in uniprocess machine, the operating system needs to be exploit the available hardware parallelism to achieve the best performance. Next is the reliability and fault tolerance. Okay, so these are the design consideration you guys have to know. So cache coherence. You guys can read by yourself. What is cache coherence? Yeah, directory protocols and so SNP protocols. So this guy, you guys can read by yourself. Okay. They write invalidate. Okay, multiple readers, but only one writer at a time. So what is for write invalidate? So when a write is required, okay, all other caches of the line are invalidated. So writing processor has the exclusive chip access until the line is required by another processor. So if you want to write something, okay, into the memory system, so it will take over, the processor will take over the processor. So most widely used commercial multiprocessor systems such as x86 architecture. So state of every line is marked as modified, exclusive, shared, and invalid. So can be multiple readers and writers. When a processor wishes to update a shared line, the word to be updated is distributed to all other caches containing that line can be updated. So before this, we have one processor have a cache, right? So this one will be updated, distributed to all other caches containing that line can update it. So any lines, so it will update. Did you guys, did Dr. Fadila cover cache memory?
Yes, doctor. She covered it.
Okay. So what's the function of cache memory? What's the function of cache memory? Anyone? Nice. What's the function of cache memory? No one knows. Okay. Let's say, for example, processor wants to read something. Okay. Let's say processor want to read something. So processor has to take the data from where?
From the memory.
From memory, right?
Right.
Okay. So when it takes the data from memory, so first it will copy the system, the memory, the data into the cache memory first. then only it will process the data. If let's say it wants to access again the data, it doesn't need to go to the memory, main memory. It will just go to the cache and it will take back. If let's say, for example, you didn't open any file for a long time. So when you open again, it will take some time to open, right? Correct or not? In your
Yes.
PC. In your PC, in your laptop, any files, if you didn't open for a long time, it will take some time to open first time. Then after you close, if you open again, it will be faster. Did you notice that or not?
Yes.
Okay, why it's happened actually? Because for the first time when you open, it will go to the external memory, or if you, let's say, for example, you store in your hard drive, it will go to the external memory and it will fetch and it will process. But before processing, it will copy the copy into the cache memory and it will process again. If we close the file and you open again, it will be faster compared to the previous one. So that's why we have cache memory here. But cache memory is temporary. Okay, if you didn't use for a long time, okay, any data, any files, if you didn't use for a long time, it will be deleted from the cache memory. Okay, because the new data, new files will keep on updating into the cache memory. Okay, yes or not? Okay, so that's why we have multiple copying system. Okay, we have what to say, different types of copying methods, okay, into the cache memory. For example, okay, wait, but okay, so we have mapping system, right? Okay, mapping functions. We have direct mapping, associative mapping, and set associative. So direct mapping, okay, we have different methods of mapping system. It will map. Mapping function means it will map the file into the cache memory, okay, before it processing it, before it goes to the processor. Okay, so that's why we have CPU, cache, main memory. So it will fetch from the main memory, okay, or external memory. Then it will copy into the cache memory before go to the CPU. Okay, so once if it wants to fetch again, it doesn't need to go to the main memory or external memory. It just go to the cache and it will process. Okay, so that's why we have cache. Okay, so I hope you guys understand the function of the cache, right? So cache, for the mapping function we have, so how to map, how to copy. So mapping means copying lah. Okay, mapping means copying something. So we have three types of mapping function: direct, associative, set associative. Okay, so we have direct mapping. So this is how the direct mapping is done. Then after that we have associative mapping. Okay, so this is how the associative mapping done, and we have set associative. Okay, we have different types of methods of set associative mapping. Okay, so multi-level caches, we have also multi-level caches, right? Level 1, level 2, level 3, right? So this is why we have cache system. Okay. I hope you guys understand lah. Okay. So when a processor wishes to update shared line, okay, the word to be updated is distributed to all other caches containing. Okay. So let's say, for example, it will distribute to all other caches containing that line can update it. Okay. Some systems use an adaptive mixture of both write invalid and write update mechanism. Okay, this is Messi protocol, MESI, not the Argentina Messi. Okay, this is to provide cache consistency of SMP, synchronous symmetrical multiprocessor, the data cache supports. Okay, protocol MESI. So this is modified the line. Okay, so you guys have to know. Okay, this is modified. The line in the cache has been modified and is available only in the cache. Okay, exclusive. The line in the cache is the same as is the main memory and is not present to any other cache. Okay, this is MESI lah. Okay, modified exclusive shared invalid. Okay, the line in the cache is the same as that in main memory and may be present to another cache. This is shared. Okay, and invalid. So the line in the cache does not contain valid data. Okay, so this is modified exclusive shared invalid, right? So you have to know what is modified, what is exclusive, what is shared, what is invalid. Okay, so this in table you can know lah. Okay, modified means what? Okay, the cache line is valid. Yes, 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 no. So the memory copy is out of date, valid. So you guys can understand lah. Okay, better on the table. Okay, right. Okay, so the next is the multi-threading and chip multiprocessors. Okay. Okay, so processor performance can be measured by the rate at which it executes the instructions. Okay, so the performance of the processor can be measured by the rate at which it executes the instruction. So MIPS rate is equals to F times IPC. So F is equals to processor clock frequency in megahertz, IPC's average instruction per cycle. So increase performance by increasing the clock frequency and increasing the instruction that complete the complete during cycle. So multi-threading. So what is multi-threading? Allow for high degree of instruction level per without increasing circuit complexity and power consumption. Instruction stream is divided into several smaller streams known as threads. Okay, that can be executed in parallel. So this is what you guys have to know. Instruction stream is divided into several small streams known as threads that can be executed in parallel. Okay, so definition of the threads and processes. Okay, so you guys can read by yourself this one. So there are two types of multi-threading. Okay, implicit and also explicit. So all commercial processor and most experimental ones use explicit multithreading. So concurrency execute instruction from the different explicit threads. So interleave instruction from the different threads on shared pipelines or parallel execution parallel pipelines. So implicit means implicit multithreading is concurrent execution of multiple threads extracted from a single sequential program. So this is implicit threads defined statistically by compiler or dynamically by the hardware. Okay. Okay, so operating system design issues here. So what are the issues? There are several issues here. Okay, so how failures are managed depends on the clustering method used actually. Okay, so two approaches, highly available classes and fault tolerant classes. Failover, the function of the switching application and data resources over from a failed system to an alternative system in the cluster. So failback, so restoration of applications and data resources to the original system once it has been fixed. Load balancing, incremental scalability, automatically include new computers in scheduling, and middleware needs to recognize that processes may switch between the machines. So this is the design issues. Okay, so how these issues are, how the failures are managed depends on the clustering methods used. Okay, so parallelizing computations. So effective use of cluster requires executing software from single application in parallel. So three approaches. Okay, parallelizing compiler, parallelized application, and parametric computing. Okay, so what is parallelizing compiler? Parallelizing compiler determines a compile time which parts of an application can be executed in parallel. Then these are the split off to be the assigned to different computers in the cluster. So parallelized application is application written from the outset to run on the cluster and uses message passing to the move data between cluster nodes. For parametric computing can be used if the essence of an application is an algorithm or program that must be executed large number of times. So each time with the different sets of steering condition and parameters. So these are the three approaches, okay, for the parallelizing computations. Okay, so this is the cluster computer architecture, right? So we have high-speed networks, network switch here, right? So this is the cluster middleware, and this is the parallel programming environment. So this is how the network is organized, okay, for the cluster computer architecture. Okay. So it's actually used for the servers, okay, servers connected to each other, right? Okay, so we use this method for that. Okay, this one you guys can study by yourself. Okay. So cloud computing, yes, cloud computing is the one. Cloud computing, all the servers, computer servers, how it's connected to each other. Okay, it's all parallel processing. Okay, so how it's uses the processes from the multiple PCs when the server is not utilized, so it can utilize this processor from the different PCs to perform to execute the instructions. So clusters compared to SMP. Yeah. Okay. Both provide you need to know the differences of these clusters compared to the SMP. Okay, so both provide a configuration with multiple processes to support high demand applications. Both solutions are available commercially. Okay, so for SMP here, okay, easier to manage and configure, much closer to the original single processor. Okay, much closer to the original single processor model for which nearly all applications are written. Less physical space and lower power consumption, well established and stable. Okay, for clustering it's usually used for the servers. Okay, in servers we have multiple PCs, multiple different servers, right? Okay, for cloud computing we have servers. So this is how. So it uses the processors from different PCs. Okay, so we do the cluster for that. So far superior in terms of incremental and absolute scalability, superior in terms of availability. All components of system can readily be made highly redundant. Okay, this is difference between SMP and clustering. Okay, so you guys have to know the difference lah. Okay, cluster and also SMP. Okay, what is so cluster is alternative to the SMP lah. Okay. Okay. Okay, this is SMP. Okay, you guys have to know what is SMP. What is the characteristic of the SMP? Don't memorize. Question 5 is design question. Okay, the design question, you have to understand and you have to design. Okay, you have to understand and you have to design. So try to understand what is the characteristic of the SMP. Okay, and what is the differences between clusters. Okay. Okay, comparison. Okay, comparisons between the cluster and also SMP lah. Okay, so what is NUMA actually? NUMA, non-uniform memory access. So this is alternative to SMP and clustering. Okay, uniform memory access, UMA. Okay, so all processors have access to all parts of main memory using loads and stores. Okay, so all access of the regions of memory is the same. Access time to memory for different processors is the same. Okay, so non-uniform memory access is NUMA. All processors have access to all parts of main memory using loads and stores. Access time of processor differs depending on which region of the main memory is being accessed. Different processors access different regions of memory at different speeds. Okay, so this is non-uniform lah. Okay, this is uniform memory. Okay, this is non-uniform because different processors access different regions of memory at different speeds. Okay, so you guys have to understand that. why it is called as non-uniform. Okay, cache coherent NUMA, a NUMA system in which cache coherence is maintained among the caches and various processes. So this is the different types of memory access. Okay. So you can study, you can see the differences between these here. So SMP as a practical limit. Okay, SMP has a practical limit to number of processes that can be used. Okay, bus traffic limits between 16 and 64 processes. Okay, this one in cluster, each node has its own private main memory. Okay, application do not see a large global memory. Coherency maintained by the software rather than hardware. Okay, so it's more on the clustering method. So combining few processes from different PCs. Okay, so it's depends maintained by the software itself rather than the hardware. Okay, so NUMA retains SMP flavor while giving large scale multiprocessing. So objective of NUMA is to maintain a transparent system-wide memory while permitting multiple processor nodes, each with its own bus or interconnected system. So this is the objective of a non-uniform memory access. Okay, NUMA system. So this is the organization of the NUMA system, right? So you guys can read how it's actually organized. Okay, so this is interconnected network here, right? We have a class, we have a system here, system here, system here. So how it's interconnected and how the processing is done together. So what is the NUMA's pros and cons here? So main advantage of CC-NUMA system is that it can deliver effective performance at higher levels of parallelism than SMP without requiring major software changes. Okay, bus traffic on any individual node is limited to a demand that a bus can handle. If many of the memory access are to remote nodes, performance begins to break down. Okay, so you guys studied about the computer network, right? Networking system, right? Okay, so it has to be connected to each other. Okay, so it utilizes. So let's say, for example, few computers are connected together, but only few PCs, only one PC is being utilized. Other PCs are not being utilized. So it can use that processor, the PC's processor, to fasten the process in the current PC. Okay, let's say for example, PC A is doing the process, and there is PC B, C, D, E is not being utilized or doing nothing. So it can use the processor from the different PCs. Okay, so it can utilize to fasten the process in the PC A. So does not transparently look like an SMP. Software changes will be required to move in an operating system and applications from the SMP and CC-NUMA system. Okay. So cloud computing elements, okay, you guys can read by yourself. Deployment model, right? So, okay. This is what covered in this parallel processing, right? Okay. Any questions so far? Any questions so far? Or you guys just need the tips? Okay, no questions. So parallel processing is just that you guys, it's a difference. If you guys did the mini project, okay, if you guys did the mini project, it's a single cycle CPU, okay. So all the instruction is executed one by one, okay. So it will take some time to execute instructions. It's not practical to use the single cycle. But as for mini project, I'm giving that for you guys to understand. At least you guys, because you guys already did the labs before that, right? Okay, you guys did starting from the registers, then after that you go to ALU, then after that you do the memory system, RAM, ROM, okay. Then after that you guys did the data part method, okay. Then you guys did the control unit, okay, in the lab module. Then after that you guys did the mini project, right, for single cycle CPU system. So this is how the subject is organized, okay, so that you can understand how the architecture of the computer is working. So this is for the parallel system, parallel processing. Okay, we use multiple processors, okay, instead of single processor, but we have different method of utilizing the processors. Okay, so we have SMP here. Okay, so symmetric multiprocessor. So what is symmetric multiprocessor? And we have clustering method. Clustering. Okay, clustering means what? And we have NUMA. Okay, non-uniform memory access. So we have three types lah: symmetric multiprocessor, and clustering, and also NUMA. So in NUMA itself, so in SMP, so you guys have to read what is the characteristics of the SMP here, right? Then after that, for the clusters, okay, what is cluster actually? So alternative to SMP approach providing high performance and high availability. Okay, so particularly effective for the server applications. Okay, so in server we have multiple PCs, right? So how it's actually utilized by combining the processors from the different PCs to execute the instruction or execute one program in a single PC, right? So we use the cluster method here. Then after that, so what is the comparison between SMP and clusters? And we have another method, alternative to SMP and clustering. We have non-uniform memory access. So what is that non-uniform NUMA method? Okay. Okay, so far you guys understand? All good? All good or bad? Why Vikris? Vikris is thinking. Give some feedback, guys. Okay or not? Hello, guys. Are you guys okay?
Okay, sir.
Already get prepared for your exam? Okay. So hope you guys do well in your finals. Yeah, Hamad. Any questions? So I hope you guys can do better lah. Okay, so I already help you guys as I can, as far as I can. Okay, so I already reduced the scope for you guys. Okay, for chapter internal memory. Okay, internal memory, try to focus on the error corrections. Okay, try to focus on the theory lah, rather than the calculation. So try to understand, okay, what is error correction itself. Then after that, for external memory, for the external memory, you guys study on CD-ROM. Okay, try to understand on the CD-ROM part. Then after that, for chapter input output, okay, chapter input output, what I tell. Okay, try to understand. What is the program input output. Okay, interrupt driven input output. Okay, and also DMA lah. Okay, so what is the drawbacks? What is the advantage of DMA? DCA. Okay, so what is DCA? Direct cache memory, direct cache access. Okay, what is the advantage of that? Okay, try to understand that. That is for input output. Then for performance issues, try to read on the multi-core. Okay, on the loss, under loss and inter loss, right? Then for chapter 5, chapter parallel processing here. Okay, so parallel processing actually is using multiple processors. Okay, so we have three types of multiple processing technique. We have SMP. So SMP means within the computer, within one PC itself, we're using multiple processors. Okay, and we have clusters. Cluster means is usually used for servers, and also we have non-uniform memory access, NUMA, right? Okay, so we have three types. Okay, so one tips for this chapter. This chapter I asked in question 4 and 5 lah. It's a optional. This will be an optional question and design question. So you guys have to design something. Okay, so that's the tips lah that I can give. Okay,